students. Hope you are all fine. Welcome back to our paper Programming in C. In the previous class, we have learned about the character set, tokens in C, keywords and identifiers, constants, type of constants, and we had a glance to the variables also. Now that we move on to the topic data types. Any data, whether it's a constant or a variable, must be declared before we use it in a program. The declaration is done by specifying the types of identifiers, and we have learned the rules for forming the identifiers. Some data may be numbers, that may be integer or real numbers, or some may be formed by using letters. So while declaring, we use some data types to specify the types of data that we might use in our program. So all the data or the variables and constants that will be used in a program should be declared already before making use of that data. So before using the variables or constant in a program, those data should be declared already by specifying its data type. So the data type is a collection of data with values having a fixed meaning. It has a fixed meaning and it has a particular characteristics. C language is rich in its data types. These data types are storage representations, and it may vary from machine to machine, or it may vary from programming languages. It varies in different programming languages. The variety of data types available allow the programmer to select the type appropriate to the need of the applications. Now, in C programming language, ANSI C supports three classes of data types. First one is a primary, also called as the built-in data type or fundamental data type or even basic data type. Primary data types. The primary data types include void, int, char, double and float. We know int data type is used to represent an integer value. Char, C-H-A-R, char is used to represent a character, and double and float are used to represent the real numbers. So see, all the C compilers support 5 fundamental data types. That is integer, represented as int, character, char, floating point, that is represented as float, float keyword, and double precision floating point, that is double, 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 and void. Many of these also offer extended data types such as long int and long double. Primarily, the built-in data types are void, int, char, double and float. C supports other data types also, derived data types, array, reference and pointers, and also the user-defined data types, structure, union and enumeration. So void, the first data type, void. Void is used to represent that it holds no value. It is generally used for specifying the type of function or what it returns. In case it returns any integer value, we must specify as int. If there is no value is returned by a function, we specify it as a void function. If the function has a void type, it means that the function will not return any value. So for functions that return no value is represented by the void type. It is also a primary data type. Void is a primary data type that is used to represent that the function returns no value. The next primary data type is int. It is used to denote an integer type. So, to provide some control over the range of numbers and the storage space, C has three classes of integer storage, that is short int, and long int. These or can be in both signed and unsigned forms. ANSI C defines these types so that they can be organized from the smallest to the largest. So a short int represents fairly small integer values, and it requires half the amount of storage as comparing with the regular int number uses. So to represent a short smaller integer to a longer integer, we can make use of these three classes of internal storage of integer values: short int, and long int. We declare long and unsigned integers to increase the range of values that can be stored. Character, as the name indicates, char is used to denote a character type. That means letters. A single character can be defined as a character char type data stored in 8 bits of internal storage, and this also applies both as signed and unsigned. Floating point numbers are stored in 32 bits with 6 digits of precision. Floating point numbers are defined in C with the keyword float. When the accuracy provided by a float number is not sufficient, the type double can be used to define the number. So a double data type number uses 64 bits with a precision of 14 digits. So this is also known as a double precision number. To provide more extension for this, to extend the precision further, we may use long double, which uses 80 bits. So for a normal floating point number is stored in 32 bits with a 6 digit of precision, and a double data type is used to store 64 bits with a precision of 14 digits, and further it can be extended by using a long double with 80 bits. So this is the three main classes of the floating point type: float, double, and the long double. As we see in the table, the values, the range of values and the storage sizes are mentioned in the table for different types: character, unsigned char, signed char, int, unsigned int, short, unsigned short, long, and unsigned long. You just go through the values, the storage size, and the value ranges given. So these are all the primary data types supported by the C language. The primary data types, as we learned, are of mainly three types: integer, character, and floating point type. Also, in case of no return values, we may use void along with the functions. So these are all the primary data types: integer type, character type, and floating point type. And within this, we have further classification for integer as int, short int, and long int. And again, it can be extended to the signed and unsigned type. For characters, we use char keyword, and it of course can also be used as signed and unsigned character. For floating point type, we may use the float to represent 32-bit numbers with 6-digit precision, and double as an extended usage to store 64 bits along with the precision of 14 digits, and further it can be extended as a long double that uses 80 bits. And the void type, as we said, it is used to represent that the function returns no value. So these are all the primary data types used in the C programming language. The primary data types or the fundamental data types, it can also be said as the basic data type or the built-in data types that we may use as such, and the particular keywords are used to represent this data as int, float, char, double, etc. So these are all keywords that are used to represent the data types, basic or the fundamental data types. And the next one is the derived data types. C supports 3 derived data types: arrays, references, and pointers. Arrays are sequences of data items having homogeneous values. That means we use arrays to specify similar values. A collection of similar values can be represented using array. For example, to represent a series of numbers or a series of characters, a name of a person, etc. For such purpose, for representing similar values, we use the derived data type array. They use consequent memory locations, adjacent memory locations, to store the values specified inside a array. References, function pointers allow referencing functions with a particular signature that we may learn on our next sessions. Pointers, these are the powerful C features which are used to access the memory. Pointers are used to access the memory locations. That means we are dealing with the memory addresses. When we deal with the memory addresses, we make use of the pointer values. So arrays, references, and pointers are the derived data types that are supported by the C language. And the next one is the user defined data types. In programming and in C, we make use of type definition that allows the programmers to define their own identifier that would represent an existing data type. There are 3 types of user defined data types: structure, union, and enumerated data types. Structure, it is a package of variables of different types under a single name. That means we make a union, or a unit of data can be united together to form a structure. For example, we may construct a class of students can be represented as a structure. So forming a group of similar data as a single unit is called a structure. For this, we make use of the struct keyword. Struct is the keyword that is used to define a structure. And union, similar to the structure, this also allows to store similar data types as a single unit. Also, by using the union user defined data type, we can specify different members, different data types also. Different members of different data types can be specified with the union. And enumeration, it is a spatial data type that consists of an integral constants, and each of them is assigned with a specific name. Here enum is the keyword, and we can specify it is just to make a union of or a collection of data. These all terms, these all user defined data types are used to specify a collection of data items, whether it belongs to a single data type or a different data types. The the different collection of members can be united together by using these user defined data types. So these are all about the data types used in the C language. Keep learning. Thank you.